Let us study the first example. Find the solution set of the quadratic inequality x squared minus 4x is greater than 12. In dealing with quadratic inequalities, the first thing that we should do is to get 0 on one side of the inequality. In this case, we need to add negative 12 on both sides of the inequality in order to have x squared minus 4x minus 12 is greater than 0. The next step that we should do is to get the factors of the quadratic expression. In order to get the factors of the quadratic expression x squared minus 4x minus 12, get the factors of x squared. That is x times x. Then get the factors of negative 12 such that the sum of the factors is equal to the coefficient of our middle term, which is negative 4. And that is negative 6 and positive 2. The factors of x squared minus 4x minus 12 are x minus 6 and x plus 2. So we have x minus 6 times x plus 2 is greater than 0. Let us equate both factors to 0. So we have x minus 6 equals 0 and x plus 2 equals 0. Then solve for the value of x. In x minus 6 equals 0, if we add positive 6 on both sides of the equation, we get x equals 6. In x plus 2 equals 0, if we add negative 2 on both sides of the equation, we get x equals negative 2. Negative 2 and positive 6 are called the critical values of the quadratic inequality. The next thing we have to do is to plot these 2 points in the number line. We have now a number line which has negative 2 and negative infinity on the left, and positive 6 and positive infinity on the right. Mark the critical values negative 2 and positive 6 with an open circle because we have the symbol greater than in the inequality. This means that these two numbers are not part of the solutions of the quadratic inequality x squared minus 4x minus 12 is greater than 0. We have now a number line which was divided into 3 regions. These 3 regions are called the test intervals. We have the first test interval, all possible values of x lesser than negative 2. That is between negative infinity and negative 2. We have the second test interval, x is greater than negative 2 but lesser than positive 6. All values of x between negative 2 and positive 6. And we have the third test interval, x is greater than 6. All possible values of x greater than positive 6. Then, we have to select a particular value in each test interval in order to determine which test interval describes the solutions of the quadratic inequality. In this case, for x lesser than negative 2, let us test negative 3. Going back to our inequality, x squared minus 4x minus 12 is greater than 0. Substitute x with negative 3. We have negative 3 squared minus 4 times negative 3 minus 12 is greater than 0. Then we have 9 plus 12 minus 12 is greater than 0. Then we have 9 is greater than 0. This indicates a true statement. This implies that all values of x lesser than -2 are solutions of the quadratic inequality. For all values of x greater than -2 but lesser than +6, let us test x equals 0. So we have 0 squared minus 4 times 0 minus 12 is greater than 0. Then we have 0 plus 0 minus 12 is greater than 0. Then we have -12 is greater than 0. This indicates a false statement. This implies that all values of x between -2 and +6 are not part of the solutions of the quadratic inequality. For all values of x greater than 6, let us test x equals 7. Therefore, we have 7 squared minus 4 times 7 minus 12 is greater than 0. Then we have 49 minus 28 minus 12 is greater than 0. Then we have 9 is greater than 0. This indicates a true statement. This implies that all values of x greater than +6 are part of the solutions of the quadratic inequality. Since all values of x lesser than -2 and greater than +6 make our quadratic inequality a true statement, then the solution set of the quadratic inequality x squared minus 4x greater than 12 is -infinity to -2 union +6 to +infinity, or all values of x such that x is lesser than -2 or x is greater than +6.